All right, guys. Welcome back to the Incredible Academics YouTube channel, guys. There's question that I want us to look at, and this was also part of the assignment that my learners wrote. So, and what I've realized with this question is that in fact, all of my learners thought this was a trigonometry problem, okay, and of which that's not entirely true. Yes, you can use trigonometry methods to solve the problem, but this is not a trigonometry problem, okay. And you guys will see just now, for as long as there's coordinates like that, it is definitely an analytical geometry problem. So look at what they're saying. In the diagram below, there's point P, right, and the coordinates are given, and there's also OP, which is 2 units. There's also point Q, which is has got an unknown coordinates, right? Yeah, so everything is quite clear. So now they say calculate the value of x. So obviously, to find the value of x, we just need to, if you check, this is what we have, right? You can use Pythagoras, okay, because this angle is 90. You can use the coordinate geometry formula, the distance formula, because remember point O, it's actually 0 is to 0, okay. So we know that distance, right, is given by the square root of x1 minus x2 squared, y1 minus y2 squared. This is the formula for distance, okay. This is the formula for distance. So now if you want to find the point x, which is the same as the quadratic, what's this thing, Pythagoras theorem. Basically, this is another version of Pythagoras theorem, okay. So we can substitute our distance, which is 2, and if you check, it's gonna be x minus 0 squared. Remember, we're using these coordinates and the origin, which is 0 is to 0, so x minus 0 squared, and root 3 minus 0 squared as well, and that just gives us what, the square root of x squared plus 3, okay. And then we can start squaring both sides of the equation to remove the square root. So 4 is basically equal to x squared plus 3, right, and obviously x squared is going to be equal to just 1, and x is equal to plus minus 1, okay, when you square root both sides. But obviously our answer is x is equal to positive 1, because you can see that the x value is actually on the positive portion of the x-axis, okay. So x is 1, meaning that this coordinate over here, it's 1 is to root 3. All right, not a problem. And now we've got the value of x. Now they say calculate the size of alpha. Okay, now let's talk about the size of alpha. The size of alpha here, what you need to understand is that once you can find the angle of inclination for the line OP, right? So if you can find the angle here, angle of inclination, the angle there, you know that that angle plus the alpha must give you 90, okay, right? So that unknown angle plus the alpha must give you 90. It's already given, okay. So now the angle of inclination for OP, it's basically we just need to find the gradient, and to find the gradient, because we already got OP, right? The point O is given, and the point P, we found it. Okay, so meaning that we can find the gradient. So m is equals to change in y over change in x. All right, then you substitute your point. So that's going to be root 3, which is the first y value, minus the second y value, 0, and then 1 first x value minus 0 the second x value, which is at the origin. So our answer is just square root of 3. Okay, so now we've got the gradient. Why are we looking for the gradient? Because we know there's this formula, the tangent of theta is equal to m. Okay, when we're trying to find the angle of inclination, and good thing is our gradient is positive, so meaning that it's easy for us to find the angle of inclination. We don't even need to add 180 degrees. Okay, so theta is just going to be what? Theta is just going to be 60 degrees for sure. The tangent, arc10 of root 3, that's 60 degrees indeed. Okay, so but remember we said that the missing angle, right? So that angle over there plus the alpha must give us 90. So we're just going to say the 60 degrees plus the alpha must be 90. So the alpha is 30 degrees. Okay, so we've got our alpha using analytical geometry methods. So that's out of the way. Alpha is 30 degrees. Okay, so there was no need to use what we call, trigonometry methods. Okay, so 1.1.3, determine the coordinates of Q. Now this is a very interesting one. Okay, determine the coordinates of Q. Now, how can we determine the coordinates of Q? How can we determine the coordinates of Q? Remember the two lines are perpendicular. OP is perpendicular to OQ, right? So meaning that we can actually find the gradient for OQ. Okay, we can find the gradient for OQ, and you'll see, what we're going to use the gradient for. Okay, now look, we know that the gradient for OP, we just found the gradient for OP, which was MOP was found to be square root of 3. Yes. Okay, square root of 3. So we know that M1 times M2 must be equal to -1. So square root of 3 times M2 must be equal to -1. So M2, which is the gradient of the other line, must be equal to -1 over the square root of 3. Okay, so meaning that we now have the gradient of the other line, which is OQ. So we can use that gradient to then set up an equation in terms of A and B. Okay, because M is equal to change in Y over change in X, right, which is basically B minus the 0 over over A minus the 0. So now we're now using the point Q and the point O. Okay, so there you have it. It's just gonna be what? B over A, right, which is equal to -1 over the square root of 3. Okay, so now we can express B, we can make B the subject of the formula. So this becomes -1 over square root of 3A. Okay, we can then go right ahead and use the distance formula to come up with another equation. This is what we'll call just our first equation. So that is going to be D is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so the distance is already given. It's 20 units. Okay, so 20 is equal to a minus 0 squared plus b minus 0 squared, right? I'm just using the 2 points, Q and O. So we can square both sides of the equation. So this 20 squared is equals to a squared plus b squared. Okay, but remember, we already found the expression for b. Okay, so meaning that 20 squared is equal to a squared plus minus what? That's the expression for b. Minus 1 over the square root of 3a squared. Okay, so now 20 squared, I believe that's 400, which is equal to a squared plus a squared over 3. All right, so this is just going to be what? We multiply everything by 3. This is just going to be 1200, and then 3a squared plus a squared. So 4a squared is equal to 1200. So a squared we divide by 1200 divided by 4, that's just 300. And then we square root both sides. A is just the square root of 300, 10 root 3, 10 root 3. Okay, that's just the a. So to find the b, obviously we need to go back to this expression. B is equal to minus 1 over root 3 a, right? Minus 1 over root 3 a. So the a is 10 root 3, which is what? Just minus 10. Just minus 10. So we're done, you guys. We found the coordinate, which is 10 root 3 is to minus 10 using analytical geometry methods. Okay, so yep, I know most people are like, no, there's no way you can solve this using analytical geometry. Immediately when they see, you know, that the problem looks like the you know, trig problem, then they're like, no, we're using trig. But anyways, I hope you guys enjoyed the lesson, and that's it for this episode, and peace out.